Example number 2, it says, find the points of discontinuity. Let's just look at the book. That way I don't have to write it all down. Look carefully. It says here, if a function is not continuous on a point C, we say f is discontinuous at C, and C is a point of discontinuity. Note that C need not be in the domain of f. So for example number 2, it says finding points of continuity and discontinuity. We have the greatest integer function. And it says here, find the points of continuity and discontinuity in the greatest integer function. Well, the discontinuity occurs at the integer themselves. We have a jump discontinuity at 1, jump discontinuity at 2, jump discontinuity at 3, 4, and then the same at 0, at -1, and so on and so forth. So they're continuous everywhere except for the integers. So for the function to be continuous at x equals c, the limit as x equals c must exist and must equal the value of x equals c. So the greatest integer function is discontinuous at every integer. So for example, if I look at my function here, if I approach 2 from the left, from negative infinity, as x approaches 2, my y value is 1. I have a one-sided limit there. But it's defined at 2, because that's where the closed circle is. Since the value of the function, in this case y equals 2, so when x equals 2, y equals 2. But what does it approach from the left? It approaches 1 from the left. And if I were to approach from the other way, we get the same thing. As I approach from this side, if I approach 2, the limit and the function are the same value. However, I don't have a two-sided limit, I only have a one-sided limit. So what we would do to cheat in this case would make this an endpoint continuity. But depending on the direction that we come from, it may or may not be considered continuous. So if I were to study this function as x approaches 3 from negative infinity, it's not continuous. But if I were to study it as x approaches 3 from positive infinity, then it would be considered an endpoint continuity if I considered 3 to 4 to be my relative domain. But if I go outside that spectrum, then there's nothing more I can do. We really prefer to have two-sided limits. We usually don't like to deal with one-sided limits. So that's the preference. So we do little things to try and mask that. But basically what the textbook says is that the limit of the greatest integer function equals 2, but when we approach 3 from the negative 3, but when we approach it from the positive direction, the limit is 3. So the limit doesn't exist. We don't have a two-sided limit. Well, if we don't have a two-sided limit, then it's no fun. We don't want to be involved. However, the greatest integer function right here, it has, if we look at x approaches 1.5, the limit is 1, and guess what? That's also what the function is evaluated at. So there's points of this function that are continuous and points that are discontinuous. We can only do certain calculus applications to the continuous parts. Does that make sense? Okay.